Algebra 2. Today's learning target is I can graph a system of inequalities. It is section 3.3. The definition of system of inequalities is two or more inequalities that may share common answers. May share common answers. What I would like you to do is to graph all of on the same coordinate plane and then find the intersection region. Sometimes we call it the feasible region, the intersection region, which will contain the ordered pairs that will satisfy all the inequalities. So in other words, when you take both inequalities and graph them on one sheet of graph paper, you're going to shade and you're going to find the intersection region. Whatever region has been shaded twice will contain the solutions. Quick review from Algebra 1. The three scenarios, if you have a greater than symbol, greater than, you're going to shade above your boundary line, but you're going to make sure that you draw what's called a dashed or dotted boundary line. If the symbol is a less than symbol in your problem, less than, shade below, and it's going to be a dashed boundary line. If it's greater than or equal to will make it the boundary line solid, and you're going to shade above. Less than or equal to makes it solid, less than makes it shade below. Quick reminder again from Algebra 1. If your line rises and looks like the one that you see on your screen now, then this section towards the left is the greater than section. This is the above section. And then this section is the below section. So you would look at your symbol. If it's greater than, you would shade this direction. I guess mine needs to be equal since I drew a solid boundary. And then you would shade with your pencil or color pencil or highlighter, your choice. You would shade below if your symbol was less than or equal to. Second option, when your line falls from left to right, basically when it has a negative slope, then the above section, greater than section, is going to be towards the right. This section is the less than section or below. Third option, sometimes your lines are just horizontal. That happens when there's only one variable in the problem. If your line turns out to be horizontal, then this one's just common sense. Above is going to be in this region, and below is underneath. Fourth option and final option for a line, boundary line, it can be vertical. That will only occur when there's one variable. When your line is vertical, then the region to the right is going to be above. That's going to be greater. The region to the left is going to be below. Example 1. Graph the following system of inequalities. Y minus 2x is greater than or equal to negative 3, and x plus y is less than 2. For the first problem, we're going to solve for y. I notice there's two variables, so we're going to put it in slope-intercept form. So y is greater than or equal to the negative 2x is going to become positive 2x, and then minus 3. You're going to list your slope, 2 over 1, and your b is 0, negative 3. Okay, second inequality. you're going to get y is less than just draw that one in here, can't find it. So y is less than, and then you're going to have negative x when it transposes across, and then plus 2. Your slope is going to be negative 1 over 1, and your intercept is 0, 2. Okay, so we're going to start with the first one. We're going to go to 0, negative 3. We're going to go slope up to right 1, so the graph part is exactly like just graphing a linear equation. Everything's the same so far. You can also go down to left 1. Okay, then you're going to go back and look at your symbol. It does say equal to, so we're going to connect these points that you see on the graph paper with a solid boundary line. Again, I'm using this little purple color to represent that first equation, or first inequality. And then I'm going to hold off on the shading part. I'm going to wait until I graph the second one, but this one is shade above. Okay. For the second one, do it in red. I'm going to go to 0, 2. I'm going to go down 1, right 1. Up 1, left 1. Grab my straight edge, connect the points. And excuse me, use red for the arrows. Okay, so on the first one, it did say greater than or equal to. I drew in my solid boundary line. Greater is actually towards the left, so we'll draw a little arrow there. I'll come back to that. My red equation, or red line, is a less than symbol, so what I really need to do is go back, actually, and make that dashed. So let me try that again. Backtrack here. I'm going to draw a dashed boundary line. It does not have equal, so I had to fix my mistake there. And because it says less than here, I'm going to shade below, and the below a falling line is actually this region. So we're going to shade above this line and below this line. So what I'm going to choose to do, and you can do the same thing at home, is I'm going to use a highlighter. So for this one, I'm going to use the purple color. Just kind of start at your boundary and go to the left. Kind of shade it in. Or you can do what I'm doing, just draw little lines here. Just so we know what region has answers. And then for the other one, we'll do this one in yellow. I'm going to start my dash line and go below, and so it's going to be this region. And where I've used two different colors, I think it's easier to tell where the feasible or intersection region is. And you just look for where the two colors meet, basically. And so it's going to be in this region right here. And so any point, any ordered pair that I randomly select in this region that's shaded twice will be a solution to this system of inequalities. If I pick this point that I'm highlighting in green right now, that point will not be an answer to this problem because it's on a dashed boundary. So if it's equal to, it's solid. If it's not equal to, it is dashed. And that's just to show the reader, again, that these points are not solutions to this problem. Okay, let's try another one, number 2. On the first one, I noticed there's 2 variables again. So we're going to do negative 3y. and that's greater than or equal to we got 2x and we got minus 12. And you're going to divide everything by negative 3. And when you do so, the rule from Algebra 1, anytime you have an inequality and you divide by a negative number, when this is negative, the rule says that the symbol must be changed. And so now it becomes y is less than or equal to, and then 2 divided by negative 3, and that's just going to be a negative 2/3. You will get a decimal on your calculator, but please always use fractions, especially for slopes. And then negative 12 divided by negative 3 is a positive 4. And so it looks like my slope is negative 2/3. And my b is 0, 4. Alright, and then we're going to move to the second inequality. Top this one here, it's 5y, and that one is less than or equal to, grab that, and it's negative 15. In this problem, I do not see an x, and so it's a one variable inequality. So you're just going to have to divide by the 5 because you want the y by itself. When you have one variable, always just solve for that variable. Okay, so in this problem, I've divided by a positive 5, so since it's not negative, I do not change the symbol. So I'm going to leave this alone. That's less than or equal to. And then negative 15 divided by 5 is just negative 3. Okay, so I actually have to graph both of these inequalities. And again, the second one does only have one variable. So in this type of problem, if you need to draw like a little table just to make sure that you're visualizing it correctly, that's fine. Think of it like y equals negative 3 and just put negative 3 in the y column. Just do that 2 or 3 times. And then where you don't have an x, you can pick whatever you want for the x values. Okay, so let's graph these two problems. And I'm going to start with this one. I'm going to do this one in green. I have to go to 0, 4. And my slope is negative 2 over 3, so I'll go down 2 and right 3. And then back to the beginning, I'll go up 2 and left 3. Alright, I'm going to, before I connect it, pay attention to my symbol. It is less than or equal to, means equal to, I need a solid boundary. And so this is a look at what that boundary line looks like. And then I'll come back to it in a second for the shading. Alright, next I'm going to do blue. I'm going to graph this inequality. Again, it doesn't have an x, so this one's not going to have like a y equals mx plus b mode. I'm just going to plot these points. 0, negative 3. 1, negative 3. Someone may have chosen 2, so like 2, negative 3. You may have picked negative 4, so negative 4, negative 3. It doesn't matter. But we can see, just based on the picture right now, that these 4 points are lining up horizontally. So this one's going to be a nice flat horizontal line. Okay, before I connect it, I look at my symbol, I see an equal sign, solid boundary. And then I'm going to grab my blue. There we go. Okay, so let me go back. For this falling line, which is representative of this inequality here, the symbol was less than. So if the line falls, less than would be this direction. Everything here. this inequality is less than as well. It's a flat line, horizontal line, so I would need to shade below. So again, I'm going to use highlighters. Let me grab my green. We're going to shade everything below the falling line. And you do want to make sure when you're shading that you shade all the way through. That should be good. And then we're going to go to the blue one, and it's going to be the flat horizontal line, and we need to shade below, so that will be this section. And then again, we're looking for what these two graphs have in common, and that would be the region that's shaded twice. Again, that's called feasible region, and it would be this section here. So I would like you to, especially if you're not using color, just make sure that you're darkening that section in. Okay, like on the last one, right here, this would have been the final answer. If you're just using pencil, darken it in so I can tell. Alright, comment about this problem, the third one. The difference here is I've used this in absolute value. Let me backtrack for a second. So the first inequality, I do see two variables. It's already solved for y, so all I have to do is write down my slope, and my slope here is just going to be -1. Now I do not see a number added out here. The only thing technically I can add to this problem without changing it is 0. So my y-intercept is actually going to be the origin this time. Alright, second problem is the absolute value of x plus 1, and it is less than 3. And so what I'm going to choose to do here, where it's absolute value, I have to remember from algebra that if it's an absolute value inequality, there's actually two problems. The first one's just going to be x plus 1 is less than 3. And the second problem is going to be x plus 1. And what you do to create the second scenario is you change the symbol, so it's going to be greater, and you change the sign of 3 to get -3. So when you see absolute value bars around a problem and you're trying to graph it, if it's an inequality, you have to set up two questions. The first question is going to look identical to this one, except you're going to leave off the bars. And the second problem you're going to get from changing the symbol, this is the symbol, and the sign of the last number. And then all you have to do is solve for x, because I don't see a y here. So it's going to be x is less than 3 minus 1 when I transpose. And so x is less than 2. And then over here, this is going to become x is greater than -3. And it's minus 1 when I transpose. So x is greater than -4. And so I'm just going to grab my highlighter. I got to graph this one, and this one. So this time I actually have 3 inequalities that I need to graph. Alright, let's go to color code so we can find it easier. And I would recommend you doing the same thing. So on the first one, I'm going to choose red. I'm going to go to the origin, 0, 0. I'm going to go down 1, right 1 for my slope. Okay. Alright, now for that boundary, it's going to be solid. I know that because it's equal to again, so I'm just going to connect those points. Try to get it all the way through your graph paper. There we go. And again, I always come back to the shading. Next, I'm going to do green. Okay, so we're going to look at this one. This one says x is less than 2. And again, because I only see one variable, I am allowed to kind of draw a little table so I don't make a silly mistake. If x is, let's pretend this set equal. If x is 2, that means 2 is in the x column in the table. And you get to pick whatever you want for your y. So I need to plot these points. So I'm going to go here. I'm going to go 2, 0, which is on the x-axis. 2, 1, not 2, up 1. 2, 3, not 2, up 3. And I can see just very quickly that this line is going to be vertical. Before I connect them, I pay attention to my symbol. I do not see equal sign, so I need to draw a dashed boundary. Alright, my third inequality that I need to graph is x is greater than negative 4. Again, table helps to visualize. X is negative 4. Pick your own y values. Go to your graph paper and plot negative 4, 0, negative 4, 1, and so forth. Symbol does not say equal, so again, I need a dashed boundary. Grab my blue here, and that represents, this line represents this inequality. And now we need to find the intersection or feasible region. So finally, I'm going to shade. We're going to go with, let's see, let's choose this color for the red one. This one says less than, it's a falling line. So less than is going to go this direction. Okay. All right, now my green one, I'll do here. Green says less than 2. So I got to find the one that was x is less than 2. It is this equation, or this line. Less than means shade left or below. So in this case, it is left. So I'm going to go this direction. Let me go ahead and mark the origin so we don't lose that spot. Keep that in mind. And honestly, it might be a really good idea. I didn't do this, but when there's all kinds of stuff going on in your problem, it's easy to lose your place. So it's always a good idea to label, like here's your y-axis, here's your x-axis. And that way you can find the center a lot faster. That's the origin. Alright, to finalize this, I need blue. I need greater than negative 4. Here's the line that represents that. Greater is above, and so in this case it's going to be to the right. So all of this stuff needs to be shaded blue, like the whole section. Just make it a little bit faster using these lines. And then I step back and I look at all 3 of these colors going everywhere right now. And I've got to find where the blue, the green, and the pink purple color meet. And that would be my solution set. So it looks like right in here, this is shaded by blue, green, and pink. If my eyes travel down, I see all 3 colors here as well. And here, and all the way up to that boundary line. So this region, see if I can mark it in yellow, this region right here is where your answers, like your points, are solutions to this entire system of inequalities. So again, my suggestion is make sure you use color to help you visualize. It tends to be easier to find the intersection region. And last thing I want to say is, like, again, I've highlighted it in yellow, but I can pick any random point in this region as an ordered pair, throw it back here into this problem and this problem, and it should be true. It should work. Okay, and we're going to stop there for today.